questions about Theorem 913. There we go. Which is on page, in the text, 363. So, from Theorem 912, if you look down here, Theorem 912 says, look, if we have this circle, and if we have two secants, which are in yellow here, these two secants, it says that if we look at the total length of this secant ABP, and we see that is R, and we look at this second secant, which is CDP, and we look at that as T, and we take their external segments, which is right here, S and U. So Theorem 912 says, look, the entire length of this secant times the external segment, S, is equal to any other secant here, any other one, which is kind of cool. You take that length, T, times its external segment, and those two things are equal. So look what happens here, which is pretty interesting. If we keep migrating this secant, like right here, if we keep migrating this to this point, to the point where this is now a tangent, then what happens mathematically is that length U becomes more and more dominant, because CD, if you look at this, becomes smaller and smaller and smaller. So Theorem 913 basically says, look, when we take this far enough that this becomes a point of tangency, then we can look at this and say, okay, the full-on external segment up here, which is R, and its external segment, BP, is equal to the square of the tangent segment, or BP. So once again, just to go over this, think about this. Theorem 912, R times S is equal to T times U. But just think, if we start moving this outside, then really we start having that CP here, this length, which is U from above here. This becomes more dominant, and we still use the same formula up here, AP, which is R. Sorry, this is a little confusing, and times its internal or external segment, S. So we get down here, we get R times S is equal to U squared. And then that's Theorem 913.